All right. Hey, AP Chemistry. So I'm going to make a video on question number 10 here. And this is where we have to use Q versus K in order to answer a question like A or B. And so we have this reaction. I'm going to focus on A, and then B is a little bit different. I'm going to focus on A. A is using Q versus K. And we did a little bit of notes. And we did this in class for a free response question, but we didn't spend too much time on it. I want to make a note that if Q is greater than K, the reaction is going to shift towards the reactants. If Q is less than K, the reactant is going to shift towards the products. Remember, to write a Q expression is just like a K. It's concentration of products over concentration of reactants and whatever their exponents are. For A, they give you all of the initial concentrations and you're just plugging and chugging. So we have this equation, 2 NaCl in equilibrium with 2 NO and 1 Cl2, and the Kc is 4.2 times 10 to the minus 8th. It said if 2.2 molar of NaCl, 0.004 molar of NO, and 0.002 molar of Cl2 are placed in a reaction vessel, which way will the reaction progress to reach equilibrium? Justify your answer calculating the reaction quotient. So Q of this reaction is going to be NO squared Cl2 all over NoCl squared. And so this is where I use the initial concentrations and I just plug them into this reaction quotient and I'm going to get a value. And I want to remind you, and there was like this graph that looks like this. We have a point where this is equal to K. When Q is less than K, it's going to shift towards the products. When Q is greater than K, it's going to shift towards the reactants. And this happens because if I have a large Q, that means I have too many products and not enough reactants. So like in Le Chatelier's principle, if I add or have too many products, the reaction is going to shift to make more reactants to get to equilibrium. If I have a small Q, that means I have too many reactants and not enough products, and the reaction is going to shift towards products to reach equilibrium. So now let me plug in these values. I have 2.2 is going to go on the bottom. I have 0.0044 squared, 0.0022 nothing, just to the first, over 2.2 squared. If I plug in all these values, I'm going to get a value for the reaction quotient. So 0.0044 squared. Okay, let me clear everything. So you see my calculations. 0.0044 squared, I get a number, multiplied by 0.0022. And then I divide that all by 2.2 squared. And I get 8.8 times 10 to the minus 9th. I compare this to my K value. Q is 8.8 times 10 to the minus 9th. Kc is 4.2 times 10 to the minus 8th. Q is less than K. That means I have, if Q is less than K, I have too many reactants. Too many reactants. So I'm going to shift to products to reach equilibrium. So that is how you answer A, okay? If Q is less than K, I'm going to shift to products. If Q is greater than K, I'm going to shift to reactants. My Q is less than K, so I'm going to shift towards products to make up for the small value of Q. Okay, this is exactly how we ended class last with our notes part 3 on unit 7 and looking at comparing Q versus K. The only thing you need to know how to do is compare Q to K and whether or not I'll shift towards which side. If you remember these two things, if Q is less than K, that means if Q is less than K, that means I have too many reactants and not enough products. Got to shift towards products. If Q is greater than K, that means I have too many products, not enough reactants. got to shift towards reactants. And when Q is equal to K, we're at equilibrium. We don't have to worry about shifting. Okay? And then the last question here brings us back. It says if 55.5 molar of NaCl is initially placed in a reaction vessel and allowed to reach the equilibrium in this reaction, what is the equilibrium concentration of each substance? So this, again, is just like question 9. You need to do an ice table. I am going to make that in a separate video. I just want to end this video with 10A, with you calculating a Q, comparing it to K, and figuring out which side I shift it to. I'm going to end again and saying, and remember this for the AP exam, which direction Q has to go in. Q tells me how many products I have and how many reactants I have with respect to the progress of reaction. If Q is very large, that means I have a lot of products and not enough reactants. If Q is very small, that means I have a lot of reactants and not enough products. I could compare Q to K. If Q is less than K, that means I have too many reactants and not enough products. So I have to make more products to get to K. If Q was greater than K, that means I have too many products and not enough reactants, and I have to shift towards reactants to make that reach equilibrium. So I'm going to end this video here. If you want to try doing B on your own, B is just like number 9, where you set up an ice table. I have an initial value of a reactant. I have a Kc that's very small, and I can make assumptions to figure out my products. In my next video, I will do B.